Okay. Good morning, guys. The next topic is balanced and unbalanced chemical equations. So now we go through with an activity. H2 plus O2 gives rise to H2O. This is one chemical equation. Let's take one more chemical equation. Zn plus H2SO4 gives rise to ZnSO4 plus H2. This is second chemical equation. Now see the reactants and products of number of atoms on the both sides. First, elements. What are the elements present in the equation? Hydrogen and oxygen. Okay, so number of atoms in reactant side and the number of atoms in products. So how many hydrogen atoms are there in left hand side? That means reactant side there are only 2 hydrogens are there. How many oxygens are there? Here also 2 oxygens are there. And in the product side there are 2 hydrogen atoms and 1 oxygen atom. Okay, so here on both sides the number of atoms are not equal. On left hand side and right hand side the number of atoms are not equal. Okay, so this is an unbalanced chemical equation. Okay, unbalanced chemical equation is also called skeleton equation. Okay, a unbalanced chemical equation is called skeleton equation. And next, second equation is Zn plus second chemical equation in case 2, Zn plus H2SO4 gives rise to ZnSO4 plus H2. Okay, here we have the different atoms: zinc, hydrogen, sulfur, oxygen. The number of atoms in reactant side: zinc 1 atom and product side also 1. Hydrogen atoms are both sides 2 2, sulfur 1 1, oxygen 4 atoms are there. Okay, so in the second case the number of atoms in the reactant side is equal to the number of atoms in the product side. So here on both sides the number of atoms are equal, then it is called a balanced chemical equation. Okay, so a balanced chemical equation is also called stoichiometric equation. Okay, so if you are to balance the unbalanced chemical equation, we have to follow law of conservation of mass. We have to follow law of conservation of mass. What is law of conservation of mass? Mass can neither be created nor destroyed in a chemical equation. Okay, so what is law of conservation of mass? Mass neither be created nor be destroyed in a chemical reaction. That means simply number of atoms on the left hand side is equal to the number of atoms on the right hand side. So then only the equation follows the law of conservation of mass. So in the second case, on both sides the number of atoms are same, that's why it is called a balanced chemical equation. In the first case the number of atoms are not equal, that's why it is a unbalanced chemical equation. So for balancing chemical equation, first let us take a chemical reaction. H2 plus O2 gives rise to H2O. This is an unbalanced chemical equation. See the number of atoms on both sides, reactant side and product side, they are not equal. So that's why it is a unbalanced chemical equation. So for this equation we have to balance. So how it is balanced? By equating the number of atoms on both sides. That means reactant side and product side. Okay, so equating the number of atoms on both sides, we have to balance the chemical equation. So here number of atoms on hydrogen atoms on both sides are same, but the number of oxygen atoms are different. In the left hand side we have two oxygen atoms, and product side we have only one oxygen atom. So here we have to balance the number of oxygen atoms on both sides. So by putting 2 prefix on the water molecule H2O, we have the balance the number of oxygen atoms. Here H2 plus O2 gives rise to 2H2O. So here the number of oxygen atoms on both sides are equal, but the number of hydrogen atoms are not equal. That's why it is a partially balanced equation. Now we have to balance the number of hydrogen atoms on both sides. Okay. So if you are equating the number of atoms of hydrogen atom, then it is called a balanced equation. Okay. So how it is balanced? So here the left hand side we have only 2 hydrogen atoms are there. The right hand side we have 4 hydrogen atoms. Okay. So I put 2 on the prefix of hydrogen, we get 2 2s are 4 hydrogens in the left hand side, that means reactant side. At the same time we have 4 hydrogens on the product side. So the number of atoms of hydrogen on both sides are same, and the number of oxygens are also same. That's why 2H2 plus O2 gives rise to 2H2O is a balanced chemical equation. So one more equation, Fe plus H2O gives rise to Fe3O4 plus H2. Now balance the following equation. Sorry. First we have to take the elements present in the equation: iron, hydrogen, oxygen. Okay, we have 3 different types of elements, and by observing this number of atoms on both sides, they are not equal. By observing the equation, it is not a balanced equation. That means it is a unbalanced chemical equation. So now write the number of atoms on both sides here. The different elements are iron, hydrogen, oxygen. So number of atoms in the reactant side, iron is 1, the product side 3 iron atoms are there, and number of hydrogen atoms 2 on the left hand side, right hand side 2, oxygen atoms left hand side 1, and right hand side 4. Here the number of hydrogen atoms are same on both sides, that means reactant side and product side, but iron and oxygen atoms are different. That's why it is a unbalanced chemical equation. Now we have to balance the equation by equating the iron and oxygen atoms on both sides. Okay. Next, the left hand side we have 4 oxygen atoms are there, and in the right hand side only we have 1 oxygen atom. By placing 4 in front of H2O, the number of oxygen atoms are equal. So in the left hand side 4 oxygen atoms, and right hand side 4 oxygen atoms. But what happens here? Hydrogen iron atoms are different. Now in the left hand side we have 8 hydrogen atoms, and the right hand side we have only 2 hydrogen atoms. So in the prefix of hydrogen we keep it 4 number. Okay, so by multiplying with 4 we get the same number of hydrogen atoms. So from this equation, oxygens and hydrogens are balanced. Now we have to balance number of iron atoms. So by keeping 3 in front of iron, we get the completely balanced equation. 3Fe plus 4H2O gives rise to Fe3O4 plus H2. Okay, so this is a completely balanced equation because the number of atoms on reactant side and product side are equal. That's why it is a balanced chemical equation. So a balanced chemical equation is also known as stoichiometric equation. So points to remember: every chemical equation must follow the law of conservation of mass. Each and every chemical equation must follow the law of conservation of mass, then only it is a balanced chemical equation. So what is law of conservation of mass? So the number of atoms in the reactant side is equal to the number of atoms on the product side. Okay, so an unbalanced chemical equation is called skeleton equation, and a balanced chemical equation is called stoichiometric equation. Okay, and now try this. Balance the following chemical equation. KClO3 gives rise to KCl plus O2. Second one is N2 plus H2 gives rise to NH3. And third equation, C3H8 plus O2 gives rise to CO2 plus H2O. And fourth one, PbNO3 taken twice plus Ki gives rise to PbI2 plus KNO3. And fifth one is H2SO4 plus NaOH gives rise to Na2SO4 plus H2O. So balance all these equations by the previous activity. Okay, thank you.